Welcome to the Deep Dive. We're here to cut through the noise and get you straight to the essential insights. Today, we're diving into something pretty wild. Think about this. A modern car can have over 100 million lines of code.
Yeah, it's astonishing, isn't it? More than some operating systems.
Exactly. So we're exploring software-defined vehicles, SDVs, and how software, not just steel and rubber, is basically rewriting the rule book for the whole auto industry.
That's right. And for this deep dive, we've pulled together quite a stack of sources. We've got the latest software-defined vehicle magazine from August, September 2025, various industry news briefs, some expert analyses. Our mission really is to just distill the important stuff out of this huge shift, show you how it affects everything, how cars are designed, how they actually deliver value to you, the driver, over time.
Okay, let's jump in then. Why is software-defined vehicles such a big deal right now? I mean, what does that term even, mean in practice?
Well, it's a really fundamental change. The auto industry's roots are all about physical materials, right? Manufacturing metal. Now, software is becoming the key driver for innovation, for value. McKinsey actually estimates the global market for auto software and electronics will hit something like US $462 billion by 2030.
Wow, 462 billion.
Yeah, it's huge. And get this, in some high-end cars, software alone can be like 40% of the total vehicle value. So what this tells us is car companies, they're turning into software companies fast. Their edge isn't just horsepower anymore, it's code. That changes everything: investment, who they hire, how they interact with you after you buy the car.
That shift in value is massive.
Yeah.
And here's something interesting. There seems to be this feeling that the US and Europe are kind of falling behind, especially compared to the speed of innovation in China. What's going on there?
That's what our sources suggest, yeah.
Yeah.
China seems to be operating like 50% faster in this area. They're rolling out new vehicles in maybe 16 to 20 months. Compare that to Western automakers, who are often on a 36 to 40-month cycle.
That's a huge difference. Almost twice as fast.
Exactly. And that speed gap creates really different product impressions, and serious competitive pressure. It's pushing Western companies to focus more on building communities, accelerator programs, not just relying on their own internal software teams.
Okay, so if software is now king, how does this new way of thinking stack up against how cars used to be built?
Historically, vehicle software was often kind of tacked on, is made to run on hardware that was, frankly, pretty fragmented and
Yeah.
sometimes developed almost haphazardly.
Right, lots of different little computers doing different things.
Precisely, which led to just immense complexity. The new philosophy is about purpose-built, standardized solutions. The goal is to make these SDVs cheaper, safer, and crucially, much easier and faster to get to market.
That makes total sense. So to make these SDVs work, what's happening with the underlying electronic architectures, the EE systems?
Right, the EE architecture is going through a major overhaul. We're moving away from having lots of separate, decentralized microcontrollers, think of them as tiny individual brains scattered around the car,
Okay.
towards a more unified central compute system. It's sort of like upgrading from a bunch of pocket calculators to one powerful supercomputer managing things. Companies want more processing power, but for less overall cost. This lets them build more complex, smarter features. A really solid, scalable EE architecture is like the absolute starting point, the deciding prerequisite, as one source put it. It's key for attracting developers and enabling that continuous software updating.
And is there a specific approach emerging as the favorite for these new architectures to handle all that complexity?
Yeah, the approach gaining traction is called a zonal architecture. Basically, you have a high-performance computer, an HPC, in the middle.
The main brain.
Exactly, and that's connected to several zonal control units, ZCUs, placed in different zones of the car. Plus maybe a few optimized ECUs, electronic control units, but without their own microcontrollers. This massively cuts down the sheer number of single-function ECUs by consolidating them, and allows for much faster software development cycles, especially using digital twins.
Okay, digital twin. Can you unpack that a bit? It sounds like it also helps with really practical stuff, like messy wiring harnesses.
Absolutely. So a digital twin is essentially a virtual copy, a simulation of the car, or even just a component that's constantly updated. Engineers can test software updates, run simulations of extreme conditions, predict failures, all on this virtual model before they build anything physical. It speeds things up immensely and catches problems early.
Okay, so you test in the virtual world first.
Exactly. And yes, it tackles old problems too. BMW's newer class, launching late 2025, uses a zonal architecture. They say it saves up to 600 meters of wiring.
600 meters.
Yeah, and cuts weight by 30% compared to their current cars. That alone contributes big time to a 20% improvement in overall energy efficiency. And McKinsey looked at various projects and found good architectures led to like 23% shorter development times, 74% higher productivity. And, this is really interesting, 60% fewer defects.
60% fewer defects? Wow. That's huge for quality and reliability. But does putting so much control into zones create new potential failure points or make troubleshooting harder in different ways?
That's a really good point, and it's definitely something engineers are focused on. While you get rid of wiring complexity, the complexity shifts more to the software itself and how different functions interact.
Mm-hmm.
So you need really robust software design, built-in redundancy, and much smarter diagnostic tools to manage it all. It's a different kind of complexity, but arguably one that software is better suited to handle than, tracing physical wires.
Got it.
And another really interesting solution for speeding up development, kind of related, is virtual ECUs.
Virtual ECUs. Okay, what are they and how do they fit in?
So virtual ECUs, or VECUs, are basically a way to decouple the software development from the actual physical hardware. Think about your smartphone apps. They get updated all the time without you needing new phone hardware, right? It's a similar idea.
Yeah.
BMW, for example, worked with AWS, Amazon Web Services, to create software architectures that run entirely in simulation.
So developers don't need to wait for physical prototypes.
Exactly. It breaks that dependency. Every developer can have their own virtual test bench, maybe even several, running simulated versions of the car's electronics.
So this genuinely speeds things up, development and testing.
Oh, absolutely. VECUs enable that shift-left approach we mentioned. Testing happens much, much earlier. That means better efficiency, fewer nasty surprises late in the process, and ultimately faster time to market. Plus, it makes over-the-air updates, OTA updates, much easier to manage. BMW uses this a lot already to refresh features on cars that are already out on the road.
Makes sense. Now let's shift gears slightly. How is all this SDV stuff impacting commercial vehicles, big trucks and the like?
Right, commercial vehicles, it's a big deal there too. For those manufacturers, moving to SDV means adopting that same mindset decoupling software and hardware development. But it also means a totally new relationship with their customers, extending way beyond just selling the truck. Think ongoing digital services, OTA updates for performance. Martin Lundstedt, the CEO of Volvo Group, he calls it a new era of self-optimizing trucks. The idea is that software can actively help improve the operator's bottom line, which is often really thin in that industry.
Self-optimizing trucks, I like that. How does that actually translate into real benefits for, say, a fleet manager?
Good question. Let's look at Volvo's Mack Trucks brand. They've actually been doing OTA updates since 2017. Their feature called AutoSend, which became standard early 2025, basically automates pushing out software updates. It can be done in just 30 minutes.
30 minutes without going to a shop.
Right. And the data shows trucks running the latest software have about 22% less unplanned downtime compared to trucks with older versions. That's huge for keeping trucks on the road making money. Plus, they're launching something called self-service parameter updates soon. This lets customers themselves change settings like road speed limits remotely. Again, more efficiency, less shop time.
Okay, that's a clear business case. Let's talk about robotaxis now. Lots of hype there. What's the software angle, and why is profitability proving so tricky?
Yeah, robotaxis, the software is obviously central. It's the driver. But the sheer expense of building, maintaining, and constantly upgrading these autonomous fleets is a massive hurdle. You've got hardware costs, huge R&D spends, daily operations, beating safety regulations. It all adds up. In fact, HSBC analysts recently warned it could take robotaxi operators maybe 7 or 8 years just to break even, calling a lot of the industry's own projections widely overestimated.
7 or 8 years. Wow. So given those costs, how does a company like Pony.ai even attempt to scale this?
Pony.ai is trying what they call an asset-light, AI-empowered strategy. Their latest autonomous driving kit, Gen 7, they managed to cut the bill of materials cost by 70%.
70% reduction. How?
Partly through better design, but also heavily through partnerships. This seems key. They work with automakers like Toyota, BAIC, GANC, basically sharing those big upfront hardware costs.
Okay, share the hardware burden.
Exactly. And on the tech side, they partner with companies like Tencent Cloud for the massive cloud computing, data handling, and AI infrastructure needed to run their simulation platform, Ponyworld. They use that to test relentlessly in extreme scenarios.
Makes sense to partner up. What about actually running the service and safety?
Same approach. They partner with existing taxi and ride-hailing companies like Uber for the fleet management side and dealing with local safety rules. Pony.ai claims they've logged over 500,000 hours of fully driverless operation. across all kinds of conditions. And they claim a safety record 10 times better than human drivers.
10 times safer. That's a bold claim.
It is. And their goal by the end of 2025 is to have about 1,000 vehicles operating and crucially to achieve a positive contribution margin per vehicle. So making more per ride than it costs to operate that specific car, even if the whole company isn't profitable yet.
Okay, moving beyond just driving. SDVs aren't only about mechanics or autonomy, right? How's software changing the experience inside the car? Infotainment, comfort, that sort of thing.
Absolutely. Qualcomm is a really interesting player here. They came from smartphones, obviously, but now they're building foundational tech for SDVs with their digital chassis platform. That covers connectivity, the digital cockpit, AI for driving assistance, and even autonomous driving itself. It's way beyond just showing maps. It's about reshaping the whole user interaction.
And what about on-device AI? How does that specifically change things for the driver or passengers?
Right. On-device AI or edge AI. This means the AI algorithms run directly on the car's hardware, not just in the cloud.
Okay, so it's faster, more private?
Both, potentially. It enables features like adaptive interfaces that learn your habits. Gesture recognition. Imagine pointing at a building outside, and the car tells you what it is. It can recognize who's in the car and adjust seats, temperature, music automatically. Even monitor the driver for drowsiness or distraction and, suggest taking a break or adjusting settings.
Yeah, driver monitoring sounds important for safety.
Definitely. And keeping more processing local can be better for cybersecurity too, since less sensitive data needs to be sent to the cloud. Plus, it potentially reduces data transmission costs.
We talked a lot about the complexity, what's really slowing down innovation speed across the board, and how are companies trying to fix that industry-wide?
Well, ARM points out that rolling out active safety features, for instance, is often hampered by all that fragmented hardware and custom one-off software solutions we mentioned earlier. It just leads to overly complex systems and really long development times. And that's a real problem for established automakers when they're competing against newer companies built around software from day one.
Those legacy players have a harder time adapting.
For sure. They have existing structures, processes. It's a challenge.
So what's being done to standardize things and speed up those cycles?
ARM is backing a consortium called SOFI Scalable Open Architecture for Embedded Edge. It's got about 150 members now. They're working on creating common ground, trying to bring parity, cost efficiency, and portability to automotive software. They've developed a standard firmware layer, tools like Clyde for AI software, and efficient processor cores like Neoverse. Their latest thing, Xena Compute Subsystems, announced mid-2025, is explicitly designed to cut maybe a year or more off the development time for these new AI-heavy vehicle models. It's all about building on a common, pre-validated foundation.
And getting those Western OEMs up to speed with, say, China. Any specific efforts there?
Yeah, companies like Cognizant have launched what they call an SDV accelerator. The M is to help Western OEMs compete better on speed, cost, quality, the whole package. They focus on infusing AI into the software testing and validation process, the V&V cycle, and they really push that shift left idea again using partnerships, like with Siemens' PAE 360 platform for digital twins and simulation, and Electrobit for modular software development. The idea is test hardware and software compatibility virtually super early on. Find the problems before they become expensive recalls.
It really sounds like virtual testing and simulation are becoming absolutely critical.
They are. Indispensable, really.
Now, this whole SDV thing, it sounds like it could even change how we experience classic cars.
It absolutely can, and it's already happening. There are companies like Everati. They take iconic old cars, restore them, but convert them to electric power. And they use software specifically to, as they put it, squeeze out more character, life, and future utility. They actually partnered with a company called Soda.Auto on a modular, software-defined EV powertrain.
That's fascinating. How does software add character to an electric powertrain, especially in something iconic like, say, a Ford GT40?
Well, a software-defined powertrain isn't just about making it go. It's about vehicle-level control. Taking what the driver does with the pedals and wheel and translating that into precisely how the electric motors deliver torque, how the suspension reacts. Take Everati's electric GT40. It apparently weighs less than the original V8 car, has 800 horsepower, massive torque, and does 0-60 in under 4 seconds.
Wow.
But deploying that kind of power smoothly, making it feel exciting but controllable, maybe even mimicking some characteristics of the original car, that's down to software tuning. And the cool part is they can add features later via software updates, things like advanced traction control, launch control, torque vectoring, even to cars already delivered to customers.
So the car keeps getting better after you buy it.
Exactly. They talk about reflashing some of the older vehicles so that our customers experience a continuous journey. And because they use pre-validated software and hardware blocks, they say they can cut a typical EV conversion project down from maybe 2 years to just 9 months.
So SDVs seem like they're maybe an intermediate step towards something even bigger, like an entirely AI-defined auto industry. What's the ultimate vision there?
That seems to be the direction, yes.
Yeah.
Companies are definitely looking beyond just robotaxis for the value from advanced AI, like SAE Level 4 autonomy. NVIDIA's CEO, Jensen Huang, he talks about agentic and physical AI. Agentic AI making complex decisions, physical AI interacting with the real world like the car driving itself or robots building the car. The vision includes things like simulating every single aspect of vehicle production virtually, or even turning the data centers processing all this vehicle data into their own revenue streams.
Right, selling insights from the data.
Potentially. And look at Tesla.
Yeah.
Despite recent headwinds, their whole narrative, their valuation, is increasingly tied to their ambition to be an AI company first, automakers second.
That's a really fundamental identity shift. How is this growing role of AI impacting the workforce and the traditional business models?
It's a mixed picture and
Mhm.
definitely causing some anxiety. Bosch, for example, sees AI investment as essential to stay competitive. They acknowledge some current jobs will likely become redundant,
Mm-hmm.
but they also expect new, probably higher skilled roles to emerge. However, we're already seeing real-world impacts. TomTom, the navigation company, announced 300 job cuts recently
Why?
because algorithms were taking over tasks previously done by entry-level software engineers and also some sales and support roles. This happened while their automotive business revenue was declining. It suggests that using AI to cut costs, driven partly by faith in the technology's potential, is probably going to become more common across the industry. It's reshaping jobs right now.
Okay, so wrapping this up, today we've really dug deep into the world of software-defined vehicles. From the foundational EE architectures all the way to how it impacts big trucks and even classic cars, it seems crystal clear that software is now the main battleground for differentiation, maybe even more than the physical hardware itself.
Absolutely. We've seen how companies everywhere are leaning into partnerships, harnessing AI, rethinking how they even develop cars, all to innovate faster and deliver ongoing value. It's turning cars from these static things you buy into living products that can actually change and improve over their lifespan.
So as we finish this deep dive, here's something for you to think about. If software really is the new playground for car innovation, what completely unexpected parts of owning or driving a car might get revolutionized next by these constant updates and super personalized features that SDVs promise?
Yeah, the potential is huge. It touches everything from safety to how companies make money. And honestly, we're just at the beginning. The big question hanging over the industry is how fast and how well can they adapt to make sure the software revolution actually works out well for everyone involved, especially for you, the person behind the wheel.